dear class trainers. Hope all of you are fine and safe. Now, today we will discuss with the last portion of the chapter Simple Machine, that is Pulley. So, in offline classes, I have dealt with the chapter Simple Machine, the definition of simple machine, functions of simple machine, different types of simple machine, okay, and the technical terms related with the simple machine. All these things we have dealt in offline classes. And the last portion is to be left to complete the chapter. And the last portion is left, and today we will discuss it. Okay, and that is about pulley. Now, pulley is a simple machine. Now, why they are known as a simple machine? You know that, okay? All there are 6 different types of simple machine. Okay, and why we call it a simple machine? Because they make our work easier and faster. And pulley is a simple machine. These are used to lift heavy loads as well as light loads. They are installed in a crane to lift or to transfer the construction material. These are used in the villages, okay, to draw the underground water. So many fields, in so many places, or so many ways these pulleys are used. And when we come to the definition of a pulley, now this pulley is a circular. It is a circular metallic or wooden disc. It is a circular disc which are made up of either metal or wood, and having a groove along its rim. So there is a rim here, okay, and the rim means this portion, okay, and around this rim there is a groove, and through that groove the string or the rope passes through it. Okay, it is a circular disc, okay, which is either made up of metal or a wood, having a groove around its rim and capable of rotating about a rod. Okay, capable, and this pulley can able to rotate. They can able to move. Okay, they can able to move around the point, around the rod called the axle, and this axle passes to the center of the pulley. So this is the definition of the pulley. Now this pulley has different parts here. Number one is the axle. Okay, axle actually is a long rod. Okay, this portion, and other one is the disc. This is a circular disc, and other one is the block. Block means where the frame where the pulley are fixed. Block are the frame where the pulleys are fixed. They are known as the block. And other one is the tackle. We call it tackle means the rope or a string. The rope or a string which goes around the pulley, that is known as the tackle. Okay, so these are about the pulley. And there are 2 different types of pulley. And in order to do the mechanical work, we use a single pulley. And single pulley are of 2 types. One is a single movable pulley, and other one is a single fixed pulley. This is the single fixed pulley. This is the single movable pulley. Okay. So in order to do some mechanical work, okay, we use pulleys, and this pulley can be a single pulley. Single pulley can be a single fixed pulley and single movable pulley, and other one is the combination of the pulley. Combination of the pulley means in that pulley there are the fixed pulley also as well as movable pulley also. So both the pulleys are combined, which we call it as a combination of pulleys. So to do mechanical work, we use 3 types of pulleys here. One is a single fixed pulley, other one is a single movable pulley, and the third one is the combinations of pulley. So in the combinations of pulley, the 2 types of pulleys are used here. One is a fixed pulley, other one is a movable pulley. Now when we come to the single fixed pulley, now this single fixed pulley, they are fixed at a rigid support. This pulley are fixed at a rigid support. Okay, they are fixed to a rigid support, and around the groove, the rope or a string goes around it. The string or the rope will wind around the groove. On one end of the string or a rope, the load is fixed here, and the effort is applied. Effort means the force which you apply from your body. Okay, so one side the effort is applied and other side the load is applied. And this pulley, this single fixed pulley, the axis of rotation is fixed. That means they will rotate in one place only. They will not move up and down. Okay, that means they can move. This pulley can rotate within their point, within their fixed position, within their fixed place. Okay, and this single fixed pulley are fixed to a support. They are fixed to a support. So you can see here, this single fixed pulley they are connected or they are joined to a support, and the axis of rotation is fixed. That means they will rotate within their position. They will not move up and down or from one place to another. They will not move. They will rotate within their own position. So this is the single fixed pulley. Okay. So in a single fixed pulley, okay, the groove is here. This one is the center. Okay, where the fulcrum is there. This one, the entire part is the axle. This is the center where the fulcrum is there. Other side the effort is present and other side load. Now, because of the load, now when the load is fixed here, when the load is fixed here, the string gets stretched. The string will stretch. And the condition in which the string gets stretched, we call it as a tension. Tension. Tension is the condition in which the string gets stretched by applying a load as well as by applying the effort. So therefore, when the load is fixed here on one end of the string gets stretched, okay, and the tension will be produced here, and this tension will be accelerated in the upward direction. As well as when you pull the rope or the string, okay, and the string will get stretched, and therefore the tension will be exerted in effort also as well as in upward direction. Here the load will move upward, okay, and the effort will move in the downward direction. That means you will pull the rope in the downward direction. When you pull the rope in the downward direction, the load will move upward. Okay, so therefore when this mechanism occurs or takes place after when you pull the string or the rope by applying the effort, the load will move up, okay, and this pulley will be able to rotate within their fixed point. Okay, so they will not move up and down. So therefore we can say that the single fixed pulley, the axis of rotation is fixed. Okay, now, and this single fixed pulley is a class 1 lever. Now in a class 1 lever, the fulcrum is between the load and the effort. Since the load and the effort are on the two ends, okay, so therefore this single fixed pulley is an example of a class 1 lever. Okay. Now let us find the mechanical advantage and velocity ratio of single fixed pulley. Now in case of when we consider load here, load equals to, I write it here, T, tension. Okay, load equals to T means when you apply the load or when you fix the load on this string, the string gets stretched and therefore load is equivalent to tension. Then again, effort equals to also tension. So when you apply the force in the downward direction, okay, the string will get stretched and therefore the tension will produce here. So again I write it here, E equals to T. So therefore, when I write mechanical advantage equals to load divided by effort, load equals to T, effort equals to T cancels equals to 1. Okay, so therefore the mechanical advantage equals to 1. So now the mechanical advantage, there is no gain in the mechanical advantage. Okay, mechanical advantage, there is no gain in the mechanical advantage, but these single fixed pulley are widely used. They are widely used. Now why they are widely used is that there are two reasons why the single fixed pulley, though there is no gain in the mechanical advantage, the single fixed pulley are widely used. Because number one reason is there, the effort is applied in the downward direction, okay, and if it is easier to apply the effort in the downward direction. That means this single fixed pulley will help to change the direction of the effort, because instead of applying the effort in the upward direction, okay, rather we apply the effort in the downward direction. It becomes very easy to lift a load, and by applying the effort in the downward direction, we can change the direction of the effort also. That means the direction of the effort can be changed. How it can be changed? You can, since you are pulling the string in the downward direction, you can pull from the right side also, from the left side also, that means you can change the direction of the effort there. Okay, and other reason is there, you can apply your own body weight. Okay, you can apply the own body weight to lift the load. So there are two reasons why there is no, even though there is no gain in the mechanical advantage, the single fixed pulley are widely used because of the two reasons are there. Because it is easier to apply the effort in the downward direction, or we can say that it has to change the direction of the effort. The single fixed pulley has to change the direction of the effort, and the second one is there, we can apply our own body weight to lift the load. Okay, next one, let us come velocity ratio, VR. Now velocity ratio is, let us consider, let the distance traveled by the load be d. Now how the distance will be traveled by the load? When you apply the effort in the downward, when you pull the string in the downward direction, the load will move upward. Whatever the distance, however the amount of effort you will apply, the same distance the load will travel. Okay, so if you apply the effort in a downward, you are applying the effort in the downward direction. When you pull one time only, once only you just pull it, one time it will move up. Then again you keep on pulling, what will happen there? This load keeps on moving up. So therefore, in case of velocity ratio, let the distance traveled by load will be d. Okay, distance traveled by load will be d, and the distance traveled by effort will also be d. Because by applying the effort, the load is moving upward. If you don't apply the effort or force on the other side of the string, the load will remain as it is. It doesn't move up. So in order to bring the load up, you apply the effort, and the direction which you apply the effort is in the downward direction. So whatever the distance traveled by the effort, the same distance will be traveled by the load. So therefore I have written here dl equals to d and d equals to d. So therefore velocity ratio equals to distance traveled by effort divided by distance traveled by load. Okay, so yeah, this is the formula, displacement or distance traveled by effort divided by distance traveled by load. What is given here? D equals to d divided by d equals to 1. So velocity ratio is also becoming 1. So if you calculate efficiency then, eta, efficiency equals to mechanical advantage divided by velocity ratio. Mechanical advantage is 1, velocity ratio is also 1, multiplied by 100 equals to 100%. So efficiency is 100% in case of a single fixed pulley. Okay, so this is about the single fixed pulley. So in the single fixed pulley, okay, there is no gain in the mechanical advantage also. We can use this pulley. Okay, you can this pulley are used widely. Okay, even though there is no gain in the mechanical advantage, the reason I have told you. Okay, and you can calculate the mechanical advantage as well as velocity ratio and efficiency. Okay, and the other point is there, this single fixed pulley is used to lift light loads. Okay, like to draw the water from the well. Okay, to lift a light basket and like this type of weight can be used. And the axis of rotation in the single fixed pulley is fixed. Okay, and this single fixed pulley is supported. It is fixed to a support, and the effort applied is in the downward direction. So today we have discussed the two things here. One is about the pulley, and other one is a single fixed pulley. In the next class, we will discuss about the single movable pulley and the combination of the pulley, that is block and tackle system. Thank you.